Or this computer, share screen. Okay. Sorry, can you make the text larger? Sure. Is that better? System.out.print args.length. So that's interesting as well. We've got this kind of dot syntax going on, what we call a property kind of semantic of this particular thing here. So there's a few things to think about. Now let's start by just going hello world. We'll get rid of this comment and system.out.println hello world. And we hit run. And after printing out lots of stuff, it prints out hello world. Awesome. Now, immediately you think this is a bit verbose, and this is a kind of common thing with Java where you kind of have to go to the moon and back to get anything done. And I don't say that as that's just sort of, I guess, way to approach programming in Java is it's maybe a bit more sort of verbose and a bit more kind of, you have to go around the bend and back just to do something that seems quite simple. But what this is saying is, I think system is a library and println is a function inside that, just same as in C and Python, and we pass this argument to it. And if we wanted to, what could we do? I don't know. Let's print out args.length. I won't print out like argc or argv just because that's a bit complicated with running it. Args.length is 0. Cool. Any questions on this?
So is Java similar to like C in the sense that after the name and the curly brackets, those are your like input variables into the function?
Yeah, so they're your parameters. And maybe let's define another function here, and we're going to call this one public static void hello. And what we'll just do is move this code into here. Oops, sorry. There we go. And we're going to take in a string message. And what we'll do is just kind of similar to Python, concatenate the strings and print out the message. And we'll call the hello, welcome to COMP2511. We'll call that function here. Again, you think, what's this weird public static stuff going on? We'll talk about that in a second. All right, any other questions? Cool, let's keep going. So where are we? We did this one. Okay, inside a new file called sum.java, we're going to write a program that reads in some input and then sums up the numbers separated by spaces. So on the left-hand side, this is a really nice sort of navigation panel we can use in VS Code. We can add new files just like this and say sum.java. And we're going to go public static void main string args, if I spell it correctly. And what do we want to do now? Okay, we want to use this scanner class, right? Use the scanner class. How do we do that? Well, scanner is something that we need to import, but we don't actually have to import it ourselves. And this is a great feature of VS Code as an IDE or an integrated development environment. It kind of sort of predicts what you want to do and does a bit of stuff for you. So what we're going to say is scanner equals new scanner. And we're going to pass in system.in. Now, firstly, what in the world is going on in that line? And secondly, we've got all these problems. Let's answer the second question first. What I'm going to do is command dot on Mac. I think that it's like control dot on Windows, but it says, well, here's a bunch of solutions to your problem. You know, here's some possible solutions. I'm going to pick the first one, which is import the scanner. And you don't have to worry about manually typing it out. And it kind of takes a bit of the overhead off you. And as you'll soon realize, there's a lot of overhead when we're dealing with object-oriented programming in these large, what we call enterprise scale, enterprise software systems. Okay, cool. So it added a line of code for us, and now we imported that like, you know, you would in Python or something. But what's going on here? And why have we said the word scanner 3 times? Well, what's this? Variable name, yep. What's this? Sorry. Yes, so you're right in that it's the type, the class. So we're going to talk about what's the difference between a class, an object, and a type in a second. And then we say new, which you can think of as being like malloc, right? Instead of mallocing this area of memory, we're just going to say we're making some new object. And what's this? So this one's the type, then what's this? What's a function? And you're definitely on the right track. Sorry, the scanner as well. So this is the class, or this is the this is where it gets a bit fuzzy, but you can call this the instantiation of a class, which is an object. We'll talk about that in a second. And then we pass in system.in, which is standard input, like we saw here, system.out, standard output, same thing. So we're going to read a line of input. Now, what actually happens, I'm going to bring up the OneNote so that people in the recording can see this as well. Just like when you malloc something in C, like, you know, you maybe might have done your abstract data types, like your set ADT or something, and you know, the new set goes in memory and says, okay, well, here's my memory. It's like a big grid, you know, here's my rows, here's my columns. Oops, that's messy. And it says, okay, well, maybe my scanner in this case takes up 3 bytes. So I'm going to take these 3 bytes. It's going to be my scanner. It's going to start from this area of memory here, which is like, you know, OX 1, 2, 3, 4, 5. And it goes for 4 bytes. And this sort of pool of memory is going to belong to this type. That's exactly what Java does. When you say, okay, I want a new scanner, it goes, all right, 3 bytes or however many bytes the scanner is. I couldn't tell you off the top of my head. I don't know if I can even tell you with research, but like the point is it allocates some number of bytes and says, okay, here's that space in memory. I'm going to give you back a pointer. And we'll talk about pointers probably more, maybe later today, maybe next week. And this is an object. So an object is something that you can touch and work with and say, okay, I'm going to invoke some methods on it, which we'll do in a second. And you can think of an object as this thing here. It's the actual thing living in memory. Maybe I say, okay, I'm going to make another scanner called scanner2, which is the exact same thing. And then Java goes, all right, look for some memory. Here's some more memory. Here's scanner2. And it starts at OX, whatever. So these are both objects. Now, these objects are of the same class type. So class and type, okay, what's the difference between those two? You can think of a class as being like a template. So, you know, here's my triangle, right? We'll have, pretend we have a triangle class. But this is the class. But this triangle itself isn't real as such, right? You can't touch it and work with it and call methods on it and invoke, you know, data mutations or queries or anything like that. This is just the idea of a triangle. And what we want to be able to do is say, okay, here's the idea of a triangle. I'm going to take that and turn it into concrete implementations of the triangle that we can touch and work with and do actual data manipulation. And these are objects, right? These are your areas of memory, like we talked about before. And this is the class. Now, a class could be of a certain type. And you can think of the type as the semantic definition, right? The semantic, this is what it means to be a scanner. This is what it means to be a triangle. This is what it means to be a hello world, whatever that means. Any questions on that so far? I've only written 1 line of code. So we'll get rid of this. Okay. Now, the next thing we want to do is say, well, okay, we've gotten our scanner and we want to read in a line of input from the user. So we'll say string line equals scanner dot next line. And that just says, get me a line of input from the keyboard. What we're going to do from there is split that up and say, okay, well, this is going to be an array of strings. We'll call this numbers equals line dot split. And we'll split it on space. And now we have an array which we can iterate over. We can loop over it. And this is where you can sort of think of Java as being like as a language. You know, it's like you've got C down here, you've got Python up here. Let me type this out actually. Yeah, you've got C down here, you've got Python up here, and you kind of got Java sort of hanging around the middle, where we sort of deal with pointers a little bit, but not in a raw sense. And there's all this, there's automatic memory management, and there's some things where it's abstracted over. We're going to be talking heaps about abstraction over this course, but it's not as high level as Python, where like if you go into Python and say, help int, right? This is its whole own class. So when you make a new int, you're making a whole pool of memory, whereas we deal with some primitive types in Java and work slightly at a lower level. But here, this is like Python in the sense, or JavaScript, that you can go for string number numbers. And this is just like saying for number in numbers. Okay, well, what do we want to do? We want to add them all up. So we're going to say int total equals 0. And to talk to the point I was making before, what do you notice about that variable there? What do you notice about it? Sorry? Yep. What else do you notice about the types? Sorry? Yeah, so string's capitalized, whereas int is lowercase. What does that make you think of? Does it remind you of C a bit? Yeah. So an int in Java, you think of ints in C, again, if we go back to our little memory diagram, an int in C is literally 4 bytes sitting next to each other. It's primitive, right? And ints in Java are also primitive types. So anything that is capitalized, like string, like sum, like hello world, is a pool of memory. If we like Python, where you've got this whole object and there's methods and data and all this stuff going on under the hood. And anything that's lowercase is primitive. It's a simple way to think about it. So that's a primitive type. I'm going to say total plus equals integer dot parseInt number. And then I'm just going to print out total at the end. Total. And we'll run that. 1, 2, 3, 4, 5. Prints out 15. What do you notice about line 14? Yeah, what do you notice, I guess, that's interesting or kind of stands out to you in that line? Yeah, pass in, and anything in particular, semantically or syntactically. Yeah, but it's this weird thing going on where we say integer.parseInt, and this isn't something we've dealt with before, right? Where we in our hello world example, we just called this function. We just said hello because it was another function that lived in the class. Whereas here, we're almost calling this like some external function. And we'll probably talk more about it next week, but that's what a static method is, where rather than being associated with, with an object like these triangles, it's actually associated with the idea of an object, but not the instantiations itself. So I'd say, okay, there's this method that's common to all triangles, but it only applies to all triangles. It doesn't apply to one specific triangle. So here's this method, parseInteger, which is just like a typecast essentially, and says it applies to the general idea of integers, but it doesn't apply to any specific integer. And you think, well, I mean, you could do that, right? There's some problems there, but that's how they've implemented it. Yeah, essentially a static method is associated with the class and not the object. Again, we'll really get into the nitty-gritty of this later. Don't feel like you have to understand it all right now. Are there any other questions about this program? Cool. We might run over time a little bit just to get to the next one, where we start to sort of make our own objects. The next one's called Shouter. And we are going to first make a main method, public static void main. And am I missing anything? No, that's all right. What we're going to do is this shouter is going to store a message, and we're going to be able to do some mutations and do some stuff with that message. You think, well, how can a class store information? We haven't really, talked about functions that have variables that live beyond the scope of that function, right? When you run this main function here, all the variables live inside it and they die at the end, garbage collected. But now we want some sort of persistence, I guess. So what we're going to say is, we're going to make a shouter. We'll say shouter equals new shouter. And we want to actually give it a message, which is going to be hello. Now that's going to complain on us because we haven't done it yet, but to revise, what's this? Shout it out. The type, yep. What's this? Variable name. What's this? Class or instantiation of the object. Cool. Now this is complaining at us. The constructor shouter string is undefined. What's a constructor? Well, someone said before that we were kind of calling a function, and you kind of are here, right? It's sort of similar syntax. And actually that does happen. So when we create this new object, we can say, well, I want to create a new shouter and I'm going to give it this string message, right? And we do that all the time. We did it here when we say, well, create a new scanner, we pass in system.in. What's another one? That's the only place we do it there. But we want to say, I'm going to create this object and I'm going to give it these parameters. These are sort of like the starting, the building blocks, the starting point. So I'm going to say public shouter. There's no return type. We just say public shouter and the constructor has the same name as the class. And we say string message. And that is all the parameters that are given to the constructor. And you can see now that the IDE is happy with us because it says, okay, now I've got an entry point into the class. You think, well, cool, all right, what do we do in the constructor? Well, we have to do some binding. And this is where we get into the heart of what classes are all about, where we have some functions or some methods that can do mutations on data. But where is that data? Where's that data stored? We store it in the class body. So we'll say private string message. And here we're going to say this dot message equals message. Okay, more weird stuff going on. Firstly, what is this? Does anyone want to have a go? Yes. What do you mean by the object?
I'm just thinking of this like a struct.
Yeah. Yeah, again, that's a good way to think about it. You can think of it like a struct, and a class is really kind of just a struct. You've got your struct fields here. If you think back to your C, it's like you had your struct and then you had your methods that work on the struct. We've just kind of smashed them together in one place. Sorry, what was I talking about before? Oh yeah, this. So this is this triangle, or it's this triangle. It's the object we are currently talking about. It's this one over here, or this one over here, or this one over here. And again, this is actually itself is actually a pointer where you can say, well, we might be talking about this one here. We might be talking about this triangle, or in this case, shouter at a certain memory address. And we're going to make mutations on that particular object. In this case, the data inside it. So we say, okay, well, this message, which is this thing here, is going to be the message that we got given, right? The message that's been passed into the constructor. And we need to do that for all of the variables that are passed into the constructor. And that's called the kind of binding process. Hello. All right. Let's be mate. Yeah, binding process of the parameters to the class fields. Now let's actually do some interesting stuff with this. So we're going to have a getter and a setter. We're going to say public string get message, and we're just going to return message. So now I've made my shouter, and I can actually say system.out.println shouter.get message. And what that'll do is it will invoke this method, right? And when I say method, I mean every object has these methods associated with it, has methods and data. The data we actually keep hidden. We'll talk about that next week probably. But the methods, we can say, well, I want you to get the message. And if we run this, it will print out hello. We think, well, maybe I want to change my message. So I've got to say public void set message, and we're going to pass in a new message. What can we do here? We want to update this field. Do you think we could do something similar to what we did in the constructor? What can we say? Yep. And we can actually even get rid of the this, because the only reason we had that in the first place is of what's kind of called namespace overriding, where you've got this message, you've got the message parameter that you've been passed in. We've also got this class scoped variable called message. And the Java goes, well, I'm going to assume you mean this. And so if we deleted that here, it'd go, why are you assigning a variable to itself, right? The assignment to variable message has no effect because it thinks you're only talking about this. And you say, no, actually, I'm talking about the class level message. So you say, no, this, right? The object, that message is the message that we've been given. Who's confused? Okay, good. That's fine if you are confused. So now we can just say, well, the message is the new message. Cool. And we'll say shouted.set message. I love Java. We print it out again. Lo and behold, it prints out I love Java. And then the very last one we're going to say is public string shout. Oh, shout. And that's just going to say return message dot to uppercase. Yep. We run that. I love Java. Any questions? Yeah.
What if we just do solve the problem method? What if we just
It's a great question. So instead of saying shout.get message, well, you know, why have we got this sort of middle person, right? Can't we just go straight for the money? So I'll say system.out.println shouted dot message. And we run that. It does the same thing. I love Java. Okay. What if we try to do it somewhere else? I'm going to copy all this. I'm going to put it in the sum, just below the stuff we wrote. And you see, most of that works because these files live in the same package. So they kind of know about each other implicitly. That's what this package thing does up here. It says, well, if you're in the example package and this guy's also in the example package, then they know about each other and they can create instantiations of one another. So I can say in the sum class, I'm going to make a new shouter. And everything works fine, except for this one. The field shouter.message is not visible. Anyone know why that might be the case? Yeah, private. Okay. Why do we make stuff private then? It just means we can't access it. Security. I think you're on the right track. Does anyone know what? Yeah, I feel like semantically or just like we put forward the namespace problems. That's another one. There's a bigger reason. Sorry?
Like we only want to use it on the file.
We don't want to use it on that.
Like on that specific file shout.
Hmm.
Maybe we have to use that wherever we go.
Yeah, maybe we want to actually restrict who can access the data. So security is like I get where you're coming from with that. I wouldn't say it's security, but the word is encapsulation, and we're going to have a lecture on that next week. It's really interesting. We'll talk about it in the Tute a bit as well. But actually, the idea behind object-oriented programming is that you do this thing where you hide the data in the class. So the only, like if I'm the sum here and I want to access the internals of the shouter, I have to do it through these public methods. That's what these words public mean. And the stuff that's private can only be accessed by the class itself. So why can this main method access it then? In the same, almost right? They're in the same part. Like the main method lives inside the class as well. So the main method can actually access the internals, even though it kind of acts externally, right? Where it's invoking a new instance. Does anyone find this confusing? I think I find it a bit confusing sometimes. Cool. Well, I hope that makes sense. We'll talk a lot about encapsulation throughout the course, but we will slowly start to see the motivation for decoupling objects, which is where this all comes from. Are there any questions on anything we've talked about today? I'm sorry I went slightly over time. Yeah, Luke.
So that private string, is that like a global variable that only inside of this channel?
Yeah, that's a good way to think of it. The word I would use is class scope. So it's scope to anything inside the class can access it. So if we make any method, any static method, they can all access that field. Another thing that's worth highlighting is we think, well, why are we dealing with all this class stuff? You know, I want to just write, you know, like Python where I can just write a function. So I'm going to say, you know, int, I don't know, number, return 1. And what's going on here? Well, it doesn't work. Everything in Java is a class, and everything has to be in a class. And you can have multiple classes in a file, but please don't do it. We never recommend it. You have one class per file. The class has the same name as the file, and it goes public, class, and then your class name. Every so often you might not make this public, but most of the time it will be public. Yeah. No, that's a good question. It doesn't. It's not like, I mean, right, like not every C program requires a main method. It's just your entry point to the system. And it's the same thing where, like, you could have we're going to see this, you'll see this with the assignment, where there'll be one file which is like your entry point. It's like your server.py will be writing web servers. You won't be writing the server stuff, but you can think of it like that. So that'll have a main method, so you can hit run. And then the rest of the stuff will all just be their own objects that will get called by this one kind of central main method. And these will all kind of talk to each other. This is an extremely bad diagram. I'm going to try and get the pen next week so I can make it a bit nicer. Yeah, good question.
So
if you go to the structure, you can see that this is like the file directory. So it lives inside the example directory. And why is this giving me red? It's weird. Sorry. Oh, we got rid of this. Yeah, so these are all the files that live inside the example package, and that's denoted by the package annotation at the top. So if I make a new package, and again, this is, I think there's some stuff on next week's tube, but we can talk about it now. Say hello, and then I make a new my world.java. It automatically says, well, I'm living inside the hello package because that's the folder I live in.
Doesn't the file actually have a package away there?
Yes. So if we take away that, actually, let's go to sum and then take away the package annotation. It's going to go, hang on. You told me that there wasn't any package, but it lives inside the example folder. So it actually looks at the directory structure. This is configured by something called the class path. There's a lot of stuff with Java. I just will say this now. There's a lot of stuff with Java, which is like how Java works, which you're going to kind of be grappling with a little bit over the next 2 weeks. And then you're not going to really have to worry about it because this, again, not a Java course. You kind of have to understand a couple of things about Java. Essentially, anything that lives inside this source folder, like source is like the root. So you have no package. And then the more packages you have, the more, if you had made a folder, you'd say example.hello, for example. That's a very quick explanation. It's a bit rushed, but does that roughly answer your question? Yeah, cool. Anything else? Anything else we can talk about in the lab? And yeah, any setup problems we can also talk about it then. Otherwise, thank you. We're in brass. So I'll see you there.